In this video, I'm making Galinstan, which is a eutectic alloy made from gallium, indium, and tin. First, I'm heating up some gallium in a bath of hot water. It melts at about 86 degrees, so it could melt if you just hold it in your hand. It has pretty low melting point for metal. Eutectic alloys are mixtures of metals that have a melting point that is lower than the metals that they are made of. So what I'm trying to make here is Galinstan, which has a melting point lower than tin, indium, and even gallium. This makes it a really good alternative to mercury. As you can see, after just a short time in the hot water bath, my gallium has melted. It doesn't look totally liquid because of the oxide layer that often forms over gallium, but you can see it rippling and stuff. So I'm taking it out and I'm going to add it to my small beaker. It already has some gallium and indium in it, but not enough to really affect my ratios. It took a bit of time to get all the gallium out of the beaker, but I didn't have too much in the beaker in the first place, and gallium has a tendency to stick to glass. Once I got all the gallium out of this beaker, I got some more gallium and put it into total 24 grams. In case you're wondering, Galinstan is a portmanteau of gallium, indium, and stannum, which is Latin for tin. The ratios for making Galinstan are pretty important because if you don't put in the right amounts of everything, it might not successfully make the eutectic mixture. The amounts of everything I used were 24 grams of gallium, as I said, 7.4 grams of indium, and about 3.5 grams of tin. Now I'm putting in the indium, which, like gallium, is a pretty cool metal. It's very soft, so it's easy to bend, and because of its crystal structure, it makes a squeaking sound when that happens. Also, it got its name from its indigo-colored spectral lines. It was taking a bit of time to melt, so I heated it up, and it melted pretty quickly. Then I put in my tin, which normally you'd have to get pretty hot for it to melt, but because of the indium and the gallium, it dissolved with a little swirling. Without the tin, the mixture would still be liquid at room temperature, but the tin lowers the melting point so that Galinstan will stay liquid even when water doesn't. Now you have a completely non-toxic metal that is liquid at room temperature. Thanks for watching.